I'm sure most of us would have done this. Whenever we are given a renewable energy windmill project, all we do is we grab a motor, then we make or grab some kind of a fan blade, attach the fan blade to the motor, then add the leads to a battery, switch it on and get it running. We just don't stop there, don't we? We need to add some embellishments, so we add some houses, roadways, vehicles, streets and mountains and landscapes, etc. We do this not only to conceal the wiring but to make the overall project presentable. There you go, the project is completed and we move on. But what if I said this is the most underrated way to approach a project like this? Can you tell me what this is? And this? And this? And this? Believe me, they are wind turbines. Yes, all of them. The purpose of this video is to help you approach this project with a better perspective. Trying to make a working proof of concept type tabletop wind electricity generator will cost you more and it will be much less efficient. The electricity it would generate would be so less that it might not even light up an LED. And if you choose to display the electricity that it is produced, you may need gadgets that are way too expensive. In simple terms, a small project like a tabletop wind electricity generator or a windmill to work or do some visible work, there are many steps involved. The turbine should be efficient enough to catch the wind, the generator should be efficient enough, there needs to be some way to store that electricity, there should be some way to amplify that electricity or step it up, and there needs to be some way to use it. So in short, if you really want it to work, you need deeper understanding of electronics, electrical and mechanical concepts. Let us dial back a little bit. The part where the electricity is produced, the generator, is the secondary unit, but the primary goal is to catch the wind in an efficient way so that it can do some mechanical work. A piece of paper when released from a height will just float and fall to the ground, but when it is made into a kite, everything changes. The way it is made, the angle, the wind condition enable it to soar up in the sky. When we go gliding, we have to put ourselves into the kite. A small kite won't cut it out. So we make the kite bigger, we change the shape of the kite a little bit, and we try to maneuver it manually up in the sky. When we jump with the parachute, the canopy of the parachute is catching the air and it is reducing the speed of the free fall to safe landing speed. The sail of a sailboat catches the wind and it propels the boat in the forward direction. What we see in these examples is we design something to catch the wind in a very specific way for a very specific task. So rather than clinging on to the traditional turbine design, what if we change the turbine design to suit certain geographic locations and conditions? The reason I'm bringing this up is because many like myself are not really aware of the modern new age wind turbines. We don't get to see them often and some of these models are not available commercially in many parts of the world. And to be clear, there are innovations being made in this field every day. And circling back to the concept of this video, it is not really that difficult to make a model of some of these turbines using some basic stationary supplies. We will be making a few in this video, but let me tell you that this is not a tutorial. The whole concept is only to incite your enthusiasm. There is a huge classification of turbines, but for the sake of this video, let's understand three broad categories. Horizontal axis wind turbine, HAWT, or HOT. In these designs, the axis at which the turbine rotates is parallel to the ground. With reference to the observer on the ground, its axis is on a horizontal plane. What if we change the axis like this? Well, it can no longer be efficient. So we can change the shape of the blades like these here. And now these are what we call vertical axis wind turbine, VAWT or WAT. Next, what if we remove the blades entirely and make it bladeless? Will it even work? Not straight away, but by introducing a different way to generate electricity, they actually do become operational. And these are called bladeless wind turbines. I will drop a few Google links if you are interested in this subject. Now let's make some turbines and let us start with the simplest one. I'm using these square origami papers. We don't need the entire paper though. We can mark a width of 1 cm and cut 3 strips. You can cut all 3 strips with the same paper, but I'm using different colors to help you see better. Each of these strips can be folded into half on itself. Take the first piece and pinch the open end of the first piece, forming a loop. Take the second piece and pass the 2 sides of the folds above this loop. Now take the third piece and pinch the folded end towards yourself. Take the 2 open ends of the third piece and pass it into the loop of the first piece, as if we are turning the shape of an alphabet H into an alphabet A. This step will twist the shape, which is totally fine. Keep pushing the pieces towards the center and we should be able to get a cone-like structure. When we place this on a skewer and blow air from above, it will start spinning. It may look like a vertical axis wind turbine, but it is actually spinning on horizontal axis. Because in real world, air doesn't flow like this. Let me just modify this and show it to you. I've added a stopper in the middle of the skewer and poked the skewer through the center of the turbine. I also added a piece of sticky tape so that the paper doesn't come loose. And when I bring it close to the fan, there you see. I made it in horizontal direction to show you something else. Watch it when I turn it the other way around. It still works. Remember this for now and let's make another one. The next design is a very popular one. Take a square piece of origami sheet. Draw the diagonals, make a cut on the diagonals to about 2/3, bend the petals and stick it in the center of the paper. Add some support in the center and poke a pin through it. Let us put it in front of a fan. Here's another question. Can we make it even more efficient by adding more petals? Let us try that out too. Using a circle cutter, I cut a circle and divided the circle into 8 equal parts by marking lines. Then we take 4 square origami sheets and divide each of them into 2 equal halves diagonally. We end up with a triangle that has 190 degrees and 245 degrees in each of these petals. We take one petal and align the 90-degree corner to the center of the circle and paste it. We align the next piece the same way, but we offset this by 22.5 degrees. Don't panic now. Look at the line we just drew above the first piece. This will help you. Repeat the process for the next 7 petals. For the last and the 8th petal, one side of the triangular sheet needs to slide under the first piece that we had stuck. If the glue is still wet, it should not be a problem. Now we have 8 petals. Let us bend and stick them to the center just as we did before. Now when I bring it closer to the fan, you can see it is spinning a bit faster. At least that is what I think so. Let me tell you, it looks really gorgeous, but it's a little bit bulky. So can we simplify it a little bit? I've always wanted to try this idea for a very long time. No better time than now. I cut a circle from the chart. Using the same center, I cut concentric circle and I removed it, making a ring like this. Then I cut one more circle slightly bigger than the inner diameter of the ring. Then I divide the circle into 8 equal parts, making sure I don't cut them all the way to the center. I make tiny slits on the ring in between the 8 parts. We can now slide the petals into these slits by twisting all of them in the same direction. It should look something like this. Maybe add a drop of super glue at the connections to secure it properly. This turbine is foldable and it is less bulky, easy to store as well. It works even without the outer ring, but the shape gets distorted after a few runs. Now that our confidence levels are rising, let us get a bit more serious. I had purchased this vertical axis turbine model for 100 rupees a few years ago. But now it's costing more than 1000 rupees, which is insane. So the next attempt will be to try and make this, but using only basic stationary material. And also for the sake of this video, I will be making it with only 2 blades. It should work, I guess. Let me point out that the chart I'm using is used for cutting patterns for tailoring purposes. It's thicker than a chart, but thinner and flexible compared to the cardboard. I'm cutting 4 circles here. The size is not that important in this case. Just 2 of them would do if the chart was a little bit more thicker. But I'm going to fold these over as semicircles and this way it will add to the thickness. When done, we should have 4 semicircles like these. We can determine the perimeter using calculations, but the easiest way to do is to roll the edge of the semicircle on a sheet and mark it. We can cut 2 rectangular sheets and line it with the edge of the semicircle. I'm attaching these sheets by curving it along the edge of the semicircle and securing it with sticky tape, and later glue it using super glue. We should end up with 2 hollow cylinders as shown. Looking at this shape, you know that we can make it using various kinds of household stuff. Next, I'm taking 4 thick skewers and 2 thin skewers, and you will see the purpose of doing so in a bit. I'm taking a plus connector used to connect fish tank pipes. The thick skewer can be inserted on the one side of the skewer. The thin skewer can be inserted in the center, and it should be able to rotate freely like this. If the thin skewer gets obstructed, simply trim the tip of the thick skewer. I've marked and made 2 holes on top and bottom edge of the half cylindrical hollow structure we just made and inserted the skewer. We do that for the other half, and now we can put all of them together. Now, when we introduce the turbine to the fan, it begins spinning, and this happened. But since the dry run was successful, I am going to secure all of the joints except the middle one with super glue. Cut off the excess and we are good to go. For the next one, I am going to use a foam core board instead of the chart I am using. You can use carton sheets if you want to. Note that the foam core board are 10 times costlier than a chart. The reason I am using this, it is obviously because it is easy to work with and forms a firm joint with super glue. We need 2 circles cut out from this sheet, and I am going to mark it into 4 quarters. Then I draw lines with 1 cm apart on either sides of the lines that we had just drawn. The part in between the quarters have to be removed. Once done, I can insert the skewer through both of them and set it to about 15 cm apart. I've taken rectangular strips of the same material and placed them with a slight angle and slightly bend the strips to adapt to the curvature of the circular disc. I did this for each quarter, and we have 4 fins which are equidistant and of the same size set in the same angle. Somehow this thing wouldn't spin with a fan, so I'm using an air blower to get it spinning. I must have made some mistakes. Probably that's the reason why it is not spinning at low speeds. For the next one, I'm cutting 2 circles from the foam core sheet and all those discarded pieces I had cut from the previous design. These are quarter of a circle. I'm going to make fins like we did here, but this time it is going to be 1/4 of a circle. I'm sticking all 4 of them on the larger circle at equal distance in the same direction and orientation. Then I insert the skewer from the center of the circular bottom piece and at the top circular piece. Making sure it is aligned properly, I glued them using super glue. Note that I am holding the turbine by inserting a tiny ball bearing on top and bottom. If caught with bare fingers, the turbine spinning at high speed may hurt a little bit. For the next one I am making here, it requires 3 circular pieces cut from the chart. I've divided the circle into 2 semicircles by drawing a line through the center. I take the skewer and mark its width from the edge to the center of the circle. Basically, I am offsetting the semicircle with the width of the skewer. This part will serve as a flap to be glued to the skewer later. After cutting, it should look like this: a semicircle with a flap on one side. We can fold the flap and glue only the flap to the middle of the skewer. Now we can start curving and shaping the open side of the chart like a cone. Not exerting too much of pressure, if we do this a few times, the chart tends to hold the shape. We can attach the second petal at about 120 degrees from the first one and glue it as well. We can roll all of them into a cone shape till it looks something like this. Seems familiar? Yes, it is based on the Fibonacci sequence, and this turbine is called Archimedes turbine. Do you see any similarity between this Archimedes turbine and the very first turbine that we had made earlier? Comment below on what you think. These petals seem to lose their shape after a few test runs, so I gave them some support using a toothpick. Surprisingly, for this one, I didn't even have to get it closer to the fan. It is spinning already. In summary, in this video, we saw a few different kinds of turbine and how to make them using some basic stationary supplies. Therefore, we no longer need to limit ourselves to the regular windmill model for our project. Please do note that I am not saying the HAWT or the horizontal axis wind turbines are bad or anything. They are built for a certain kind of purpose and strategically placed in certain locations for maximum efficiency. But will they be just as efficient if you scale them down and fit them on your rooftops? That's a big question, and it opens up a lot of possibilities, and we just explored a few. Hope this video was useful, and if you made it this far, please don't forget to subscribe to my channel Video Epo. It means a lot to me. Thanks and bye-bye.